Some students don't know what is this word. Okay. Okay, so your aeroplane, the body you call fuselage. Something fuselage. Spread, okay, fuselage, okay. But it is not an aeroplane, okay. So for ships, okay, you ask the SND people, they do a lot of ships. They may not know the word fuselage, but for that is how. See, going bigger is how, that's what you are doing. Right, you say. Okay, right. So this is a question. So maybe I'll draw a diagram for you. This one is giving diagram. Okay. This guy will look something like that. Sometimes, okay. Sometimes when you want to
just touch my back.
Okay, and just
You cannot move the heels back.
you want to maybe test the soil. Okay, so you will use something can be very deep. You actually use to walk whatever. So guys, this is an undersea vehicle. Okay, so obviously inside your equipment, let's see how big the answer. The answer is diameter 2.6. I think it's too small for a human being, so maybe more like a rock. Okay, guys, imagine 2.6 meter. You want to see inside, it's very frightening. Okay, claustrophobia. So maybe it's just a robot. Guys, they got the equipment inside. For the equipment to work well, it has to be an atmosphere. Atmosphere is so guys, this guy is under external pressure. Get high force tank. Okay. See. Fabricated from place. Once you see fabricated from place, you know it's more thick wall can never be made by place. Cannot okay. So this is thick wall. Okay. So let's start with the flowchart. Same thing, guys. Pressure our step are right. We are told the height. I got this funny question from asking us to be okay. This guy says, so who said the whole thing is 50? Okay, so this guy, the height is here on the model. It's amazing. Who are you? I understand the people like this one is so high, right? It's not about to be higher pressure. So really you want to be that particular, so pressure is not uniform. Whether they say already lah. Okay. So guys, the answer 2 point something compared to 50. Okay, it's more. We assume uniform, okay? This is only 5 meters. Then of course the pressure will be very big, it's comparable, it's 50. So we just assume nothing complicated. So we assume it's okay, that means the guy takes center, okay, pressure. This guy is 50. Two guys 50. Okay? The density is given 1 ton. Okay, 1 ton is okay, 1 ton. I think I mentioned this in lecture also. SMA. Okay, normally for seawater it's not 1. One is for your swimming pool water, your tap water is 1. We learned that today. Or 1 ton. Normally for that they take another 5%. Seawater is very common for them to use 1.5. Okay, or slightly higher. Okay. So guys, this one. First step, and you come down. This is a case where you do not know the size. But you have to confirm this. Okay, otherwise you can't go on because all our theory is 2D stress. So guys, if you already did that, you assume okay, you assume this will be true. After that, whatever you assume, please remember to confirm. This question, look at it. Quite nice, this was an exam question, you remember properly. Okay, but then after that, check the validity of the given assumption. So sometimes even though they will say confirm also so whatever you assume, guys. So we're going to assume this. Okay. By assuming this, we will actually be assuming sigma r equal to 0. We are also assuming phase stress. Then all our theory will be true. So guys, when you come to this, it's very important. Sometimes this type of case, you will need more marks. Those normal one you forget, so you get the 3 marks. This one, because it's important, you have to practice. Okay, so now, assume this is a sphere. Okay, a sphere all around center. This guy is under external pressure. I know everything is look like this will be compression. The formula for the sigma x is same as the internal pressure, say 2 to the minus sign. Okay, negative very interesting. No details of the joint is given. Okay, so we just use whatever. They say maximum shear. Actually doesn't matter one, I already said, okay, so we go for shear. Any question? Okay, so guys, the whole circle, so need to draw, I'll explain to you. The whole circle now is like that, H, right, the R is here, 0, assume. A dot circle doesn't mean R by 0, we must bring in the R. So guys, it's actually half. Okay. Your unit 4, remember the R is always outside of the circle. The circle is the dot, is always outside. You have to do this every time. Did it in MSD also. Okay. So we start here. You are given how max. Bottom up problem start, right, start. Now next is R here, sigma H. Okay, bring in the formula. Guy is B. After do a triangle, you go and fill out the values, guys. Sphere is form. Keep the size intact. You guys can solve, okay? Whatever is going to be must be less than 5. Okay, then you say confirm. Most circle is a 2D stress thing. So you do all this to argue up, you must get it. Okay. In the actual example, you find D. So you find D as okay, so now guys, how do you know D? Thickness is D, right? So guys, you find try this one. Not very soon. The next one, okay, now we have completed our cylinder. Travel with the sphere, let's say 2.56 gram. Well, I need to have this equipment, the equipment all because of this thing. So this guy more space to put more things inside. For example, maybe we're collecting soil, okay? Maybe to collect some soil, then go up, guys, so today is this type of thing. They collect the soil samples, and then they bring it up and you test. Not getting smarter. They test it and you don't have to bring all the packs of soil. It's very nice, right? When you bring the soil, and they take. So of course you need more space to do. Just to let you know, maybe the next growth factor, the next growth sector in Singapore should be more important. Singapore just really high, all around us is city. Our land very limited, so actually a lot of things are okay. We are actually going out to see marine biology is becoming very important. Okay, so guys, I want to test the soil. I need to put more equipment inside because there's no space to make it bigger. Guys, for a sphere, if you want to create space, what do? You change the diameter. There's only one side diameter. You change the diameter because we calculate that. Not very, very complicated. If you look at the pressure, this pressure is not very high. Okay, so maybe guys, this robot, let's say Singapore is about 10 millimeters. Maybe we have got the technology. When you see such vehicle, it's from overseas one. So maybe they get it from America where it's very, very deep, very deep. Okay, so maybe change. Not very high. Cylinder is very, very flexible. And I already explained you guys that. Okay. If you want more space, you just extend it also. It's not really, look at the submarine for example. It's not really one whole plate like that, okay? So they actually do it in modules. You must have seen movies. Sometimes, accident pull, the water coming in, right? So they do the door closed, this part flooded, this one. It also wise to do that, okay? Doing various sections. So when you don't have to carry so many things, this might be shorter. It is so convenient. The length just will not disturb the stress. Okay, it's P over T over D form factor. There's no L in the stress formula. Okay, so longer putting up the system. I already said like I think wartime, all your submarine, carry this sound, this is 10 times. This time the period of that. For commercial purposes like that. Okay. With the pressure and take it. And guys, the cylinder is not as strong. So how deep can you go? That's not. I will show you guys what's the formula. So now you know that the land doesn't come in. Difference in formula is this. This one is stress, it's twice this one. Okay, so guys, go to everything is proportional, guys. E proportional to H. Okay, the stress is the half. So guys, what's the height? This is 50. This is a cylinder. You can go to 25 times. We can't go to 50. Everything we can say, using the same place, same diameter. Okay? continue? Some people already go for a break. Do you want to continue or should we just have a break? No break, continue and walk. Continue? Continue? Continue, okay? Then you go continue, then you can come out. The standard one is very easy, BD40, blah, blah, blah. There's some special features, okay? To tell you how to argue. On the highlight view, how to read questions. Guys, always argue to yourself. Like the lecture, example, right? Usually you try all those other cases. The standard pressure vessel, guys. Okay, one more time. This is always true. Okay, don't care what you do in the longitudinal direction. Who is normal? So whether you fall, it will not affect the okay, so this is always true. I want to talk about the others. Okay, the other cases. Whether it's F bar, okay, to show you how to interpret questions, right? And this student will asking this probability or this. So that's guys, you can try this one. Last one. That is the vessel. You have this lah. What do you expect, guys? What are the loads here? Last example. It's very close to the last example. There are two loads. One and your pressure. So there are two gauges to do. There are two loads divided by two stresses, two strain gauges. So that the third one will be an extra one. It's for checking angles. Okay, so expected reading is that okay. You wish to go out. Right. This one and one tricky one. So you look at the first one. I'm doing this one because I want to at least show you a vertical cylinder. Always time horizontal. Okay, that's the vertical one. Guys, is the pressure inside or outside?
Outside.
Right.
Pressure inside.
Inside. You open up for you and show you the
Water.
water
tank. Storage tank.
So guys, this is what you see in your Jurong Island. Yeah, on the clear day there you can see a lot of these cells. Okay. They want obviously they take it out next. All of them will be in it. Okay. Some of them are even casted, concrete, whatever. Okay. So you will see all this. Of course guys, there's a cover. Otherwise the trees the leaf the bird fly over, the droppings all cannot. But guys, we purposely open it up for you.
Can, sure, understand.
Okay?
Yeah.
Alright. So I know it's a cylinder. The form is 2, okay, form factor. Next, is there an axial force? You must see which case is it now in hand condition. This is the book. Book doesn't care but always true the formula, no problem.
L.
Okay, so guys, yes, is there an axial force?
Yeah, no.
Sometimes guys, axial force only for freestanding one, like those bookshop, sometimes they have those building gears, guy transport here, is that. Okay, sometimes they climb it, sometimes they chase you around so they look for. It's that kind of thing.
L.
Okay. Next. So look at. Is it close end?
What? Close end. What?
Is it close end?
Yeah.
You must see whether close end or open. So guys,
Close end.
that is where the confusion comes in. I know the word is storage tag. Okay. Guys, we purposely open it up for you. Like I
Close
said,
end
must cover one, otherwise the book dropping off. They will cover. But if you put a covered one, some student will think it's a close end. Okay, so guys, it's open up. Now, close end pressurization. Okay, remember how is it? You must pop up. Let's say close end. Okay, I will show you. To get the pressure, you must pop it up. Remember, after you pop up, it's still atmospheric pressure. Then you must squeeze in the extra amount. That's where the pressure is not. This is the case.
No.
That is not how the pressure is, guys. So we purposely open up. You can see there's still some space. It's not topped up yet. So the pressure doesn't come from that effect. Okay, no pressurization. The pressure comes from the key is no distribution. Everybody okay?
Yeah.
Everybody okay?
Yes.
So some people don't know the pressure because of the no extra volume squeeze it. Okay, the people open up to make it very, very difficult. Okay, so guys, open end. Sigma L0 is what we say. Okay, let's say you don't see, sometimes not very clear. There are other indications to help you. Look at the question. A lot of aids there. There are other indications to tell you is what you guys now involve other check involve and then sigma 0. Two of the principal direction go to 0, you only have one view, okay? But let's say it's not very sure, open and close and whatnot. Look at the question. Okay, there are other indicators telling you this one. What are they? What did you go for this one? What are they? I list two more. There are two other things. This time we give a obvious open up. What else?
Tension.
What else? Look at the data given. You know what I'm saying?
Tension.
Data, what the data that is given. How can you tell from the data given that it is one view? Actually, two more with one. There's only one should be. A single straight gate and this guy's in the full direction, right?
Yeah.
Guys, if it's not, you need another one. One, telling you one stress. It's not sphere, no. But sphere, of course, 2D. But you put one because sigma x, sigma y. This sigma is sigma L, different. Okay, by right, you need another one. Okay, do something like that. This is the extra one, right? So no number 3, you need something like that. Okay, sphere, then you can use one. So it's already into you, okay? Into you is one thing. Another one, even more obvious one. So
The cover.
Reading question. I'm just saying there's no excuse. Oh, sir, I don't know the guidance storage. No excuse. So many things. What is the other, even more obvious one, right? Tell you it is 1G. Yeah, you see, what do you see here? Yeah.
200.
Yeah, so yeah, guys, if it is to Poisson ratio okay, that yield is question. I still remember a few years ago, Joker, okay, many students still Poisson ratio not even. There's something that invigilator is maybe there's a left star or like they don't know, then call us, run down. So many will ask me this question. In exam cannot tell them, so you just say nothing wrong with the question. Guys, when they don't give Poisson ratio, oh, they think there's a misprint. Guys, this spring missing data is very rare in exam paper. Okay, I would say it's 100% to that. 99.9% because after the lecturer in charge set the question, there's a checker in the system to check everything. Okay, it is almost a foolproof system.
Sure, okay.
Even your marking guys, MSD, you check yourself, right? This week, okay, check, okay. In the final exam, guys, you don't have, I can check. We appoint another checker. So I mark your class, let's say, I buy a class MSD. Another lecturer will be marking class, I think this final exam, okay? And then you make the point of check. So that check everything, okay? The addition of this, so guys, mistake marking is okay? Very, very rare. Alright, just to highlight this. So something so obvious, forget the Poisson ratio, then the solution for Poisson ratio. The checker would have spotted this straight away. The checker check everything, no solution, everything. And then the distribution of marks, everything, okay? So this is a clear indication. Okay. So if you don't know what storage type, you should know is one thing. Okay. I will say about this. Let's do it. So I want to run the whiteboard, guys. I'll go through the steps.